In the second of this two-part series on the innate immune response, we're going to focus on inflammatory cytokines and how they induce a local and systemic inflammatory response, and in turn, how cells of the innate immune system within that inflammatory response are able to eliminate pathogens. So back to our overview of the innate immune response. In this tutorial, we will be focusing on this portion of the innate response, the induction of an inflammatory response that can either be local or systemic, and the activation of cells of the innate immune response, with a focus today on phagocytes. Inflammatory cytokines can have diverse biological effects. One of the things that they can do is they can enhance the activation of phagocytes within the localized area that they are secreted. So inflammatory cytokines can act on cytokine receptors expressed by neutrophils or macrophages and enhance the activation of those innate immune cells. And as we've mentioned, inflammatory cytokines can induce the activation of endothelial cells, which leads to increased leukocyte recruitment from the blood. What we'll talk about briefly today is that inflammatory cytokines can also have systemic effects, including the production of a variety of systemic inflammatory markers and mediators referred to as the acute phase response, the induction of fever, and in pathologic conditions, the induction of septic shock. Inflammatory cytokines join with some complement fragments to act on local capillaries to induce their vasodilation. In turn, this vasodilation leads to the slowing down of cells of the innate immune system on the luminal surface of these capillaries. Once they slow down and stop, they're able to squeeze in between the tight junctions of these cells and migrate into the infected tissue. Now, I wanted to show this picture, which I think is rather illustrative. This is a picture of a capillary, and this is the lumen of the capillary. And what you can see within the lumen of the capillary are all these hair-like strands. These are actually referred to collectively as the glycocalyx, but what they are heavily glycosylated surface molecules that essentially act as adhesive molecules to grab onto cells as they roll through the capillaries along the lumen. Inflammatory cytokines actually increase the surface expression of these adhesive molecules, which in turn allows these cells to stop, adhere to the sides of these capillaries, and migrate into the inflamed tissue. Once these cells now migrate into the inflamed tissue, they're able to migrate towards the site of infection because they migrate along a chemokine gradient. As you'll recall, macrophages, when they're activated by recognition of pathogens via their pattern recognition receptors, produce a variety of chemokines and cytokines that induce inflammation. These chemokines obviously would be more concentrated in the areas very close to the cells that secreted them and less concentrated at areas farther away. And so when these cells, neutrophils for example, migrate into this tissue, they're able to migrate from areas of low chemokine concentration to areas of high chemokine concentration so that they can make it not only into the tissue but into the part of the tissue where the pathogens are present. Okay? And thus we get this local inflammatory response where neutrophils and monocytes can migrate across this endothelial barrier into the infected tissue and then migrate within the infected tissue directly to the site of infection. And there they can mediate their anti-pathogen effector functions. What are those effector functions? Well, I'm not going to really get into any more detail than the Intro to Immunology tutorial that you've already seen. Those effector functions include phagocytosis, a process by which phagocytes can take up and eat foreign pathogens and take them up into their phagolysosome, which is an endosomal vesicle that specializes in the destruction of these pathogens. Macrophages and neutrophils are the most classic example of phagocytes during the inflammatory response, although eosinophils and dendritic cells are also examples of phagocytes. Many of these cells, and particularly neutrophils during many inflammatory responses, also contain ready-made inflammatory granules that can then be spit out into the local environment to induce an inflammatory response. These granules have vasoactive peptides that can enhance vasodilation. These granules have proteases and other molecules that can mediate pathogen destruction in that localized environment. Neutrophils, when they enter into an inflamed tissue, typically have a very short lifespan. And as those neutrophils die, one of the things they can do is spit out their DNA into the extracellular space. And these are often referred to as extracellular DNA traps because they are rich in antimicrobial molecules, and bacteria and other pathogens can get stuck within these traps, allowing them to be destroyed by other cells of the innate immune system in the localized environment. And lastly, we won't talk very much about natural killer cells, but natural killer cells are important molecules during the antiviral response and actually can release cytotoxic granules that kill virally infected cells. So rather than destroying the pathogen directly, natural killer cells kill cells, your cells, that are infected with the virus to prevent further spread. So this leads us to the hallmarks of local inflammation, and these are often referred to as rubor, tumor, calor, and dolor. And this can also be indicated as redness, swelling, heat, and pain. And these are the hallmarks of a local inflammatory response. If you recall, vasodilation can lead to increased blood perfusion, hence the redness, increased plasma leakage into the tissue, hence the swelling, increased perfusion and metabolic activity, hence the calor or heat. And lastly, inflammatory cytokines and granule components can bind nociceptors and lead to localized pain. And so these are kind of the key hallmarks of a localized inflammatory response. And most localized inflammatory responses stay local. Inflammatory cytokines are produced, they act on local capillaries, and cells of the innate immune system cross over into the tissue and eliminate whatever insult or pathogen was causing that inflammatory response. But if that pathogen is not cleared, or if the inflammatory response continues, those inflammatory cytokines can build up to the point that they can get into the bloodstream and become systemically available. And this leads to some of the consequences of systemic inflammation. Local effects of inflammation include activation of local immune cells, endothelial cell activation through vasodilation, chemotaxis, and that local immune response that we just discussed, in which macrophages, which are tissue resident, are kind of the early warning system that the pathogen is present, and neutrophils migrating from circulation are the first responders into the tissue that those macrophages pull in. Systemic effects of inflammation can include prolonged production of inflammatory cytokines that leads to release of neutrophils from their bone marrow. So a common effect of systemic inflammation is you'll get increased neutrophil counts on CBC. You'll also often see increased hematopoiesis, and in cases of severe and prolonged inflammation, sometimes the hematopoiesis isn't able to keep up with the demand for new neutrophils, and this can lead to the increased accumulation of immature neutrophils in circulation. These are often called bands when you see them on a CBC. Systemic effects of inflammation include fevers and rashes, and in very severe cases, systemic effects can include sepsis and septic shock. You haven't learned much about septic shock at this point, but you will, and is a systemic response due to a failure of organ perfusion, systemic vasodilation, and can lead to organ failure and death. Chronic inflammation can be pathologic, not just in response to an infection, but in a variety of settings. And really, regardless of the specialty that you choose for your medical career, you will be dealing with the effects of chronic inflammation. Chronic inflammation can be found in many autoimmune diseases, inflammatory bowel disease, during tumor growth, during many neurologic diseases, cardiovascular disease, diabetes, obesity, and can induce immune dysfunction during aging. And so there's a huge area of research and a lot of interest in trying to understand how chronic infection or chronic inflammation induces pathology in all of these disease settings to determine whether it can be a target for therapy. Okay, so that is my Summary of the innate immune system, including the role of pattern recognition, the induction of cytokines and chemokines, and the induction of a local and systemic inflammatory response.